This video details the operation modes of a Mercedes 722.3 or 722.4 transmission, also known as the 4G-Tronic transmission, which was used in many popular Mercedes models between 1981 and 1996. My name is Luke Dunn, and this video is part of the senior project for my master's degree in mechanical engineering at NC State, detailing the hydraulic and electronic control of this particular Mercedes transmission. First, here is a realistic cross-section diagram of the entire 4G-Tronic transmission unit. As with any transmission gear set, there are so many mechanisms contained, it is difficult to look at a whole system at once and discern the function of the parts. Instead, let's look at a functional schematic of the gear set. Some of the parts shown as continuous pieces here are in fact composed of interlocking concentric pieces, but this diagram shows the functional relationships between the moving parts. The input shaft bringing power from the engine is connected to a Ravenel planetary gear set. This is much like a simpler three-part planetary gear set, but with the small sun gear, shown in brown, and interplanetary gears shown in blue-gray. But a Ravenel planetary gear set includes a second level of planetary gears, shown in dark gray, with the second sun gear, shown in pink. The input shaft of the Mercedes 4G-Tronic transmission is connected directly to this larger sun gear. The connection between planetary gears is such that both sun gears operate independently. However, both sets of planetary gears are fixed relative to each other by the planet carrier, shown in orange, and the outer planetary gear set connects to the ring gear, shown in red. Here is a video of one operation mode of the Ravenel planetary gear set at the input of the Mercedes 722.3 transmission. Here, the planet carrier is fixed, which drives the motion of the remaining components due to power input at the input shaft and large sun gear. Returning to the functional diagram, on the right side, notice the rear output level of the transmission system, which also includes a basic planetary gear set. In the output gear set, the sun gear, shown in light blue, is hollow, and the planetary gears, shown in yellow, are fixed to the planet carrier, which is light green. The rear planet carrier is also locked to the output shaft. This means that the output shaft is driven by the planet carrier of the rear planetary gear set. Uniquely, the front Ravenel planet carrier, shown in orange, serves as the ring gear for the rear planetary gear set. The final important elements of the functional diagram are the 6 controlling mechanisms in the transmission, which can lock or unlock components to form the different drive modes and gear ratios. There are brake bands, shown in dark blue, which lock a rotating component to the frame of the transmission, stopping the rotation. There are also 2 clutches consisting of friction plates, which lock rotating parts together to link their angular velocities and restrict interior gear motion. The clutch K1, shown in brown, linked to the small Ravenel sun gear, locks the relative rotation of the small sun gear and the planet carrier of the Ravenel gear set. Clutch K2, shown in purple, locks the relative rotation of the Ravenel ring gear in red and the rear sun gear in light blue. The outer wall of clutch K2 serves as a mechanism to independently lock the rotation of the rear sun gear in light blue. The 6th and final control mechanism is a one-way freewheel clutch or sprag clutch. This connection, shown in hot pink, prevents reverse rotation and also locks the Ravenel ring gear in red to the rear sun gear in light blue. Now on to the gear modes. Here is a fully functional model of the 722.3 transmission I created using Solidworks. The scaling on some parts has been adjusted to emphasize functionality, and patterns have been applied where appropriate to emphasize rotation rates. First, a neutral rotation occurs when no parts are locked, or even when selective single controls are locked. For example, the mode shown here has engaged only brake band B3, which locks the orange Ravenel planet carrier at the input level. In first gear of the 4G-Tronic transmission, brake band B2 in the rear is engaged along with clutch K2 and the freewheel sprog clutch. This locks the rotation of the light blue rear sun gear and the red Ravenel ring gear. In this cross-section view, note the fixed gears in red and light blue, and the relative rotation rates. Input power from the pink sun gear is transferred to the rear gear set via the orange planet carrier. A reductive gear ratio of 3.68 is achieved. In second gear, brake band B1 in the front and B2 in the rear are engaged. This locks the rotation of the brown small sun gear in the front and light blue rear sun gear. Note that they remain fixed in the cross-section view, and also note the relative rotation rates. Input power from the pink sun gear is again transferred to the rear gear set via the orange planet carrier, although at a faster angular speed than in first gear due to the now mutually rotating red Ravenel ring gear. A reductive gear ratio of 2.41 is achieved. In third gear, clutch pack K1 in the front and brake band B2 in the rear are engaged. This locks the relative rotation of the entire Ravenel gear set in the front, so all these components rotate together. In this cross-section view, note that only the light blue rear sun gear is fixed, and note the relative rotation rates. Input power from the pink sun gear is transferred to the rear gear set via the orange planet carrier at a faster angular speed than in second gear, due to the now unified angular velocity of the pink input and orange rear ring gear. A reductive gear ratio of 1.44 is achieved. The 4G-Tronic transmission only has 4 gear modes, so fourth gear is a direct drive mode. Clutch pack K1 in the front and clutch pack K2 in the rear are engaged. This locks the relative rotation of the front Ravenel gear set and rear gear set so that all components front and back rotate together. In the cross-section view, note that there are no fixed gears. Input power from the pink sun gear is directly transferred to the output shaft, resulting in a gear ratio of 1. For reverse gear, a brake band B3 is engaged in the middle, along with clutch pack K2 and freewheel sprog clutch in the rear. This locks the Ravenel planet carrier in front, fixing the planetary gear's positions. Engaging clutch pack K2 and the sprog clutch locks the relative rotation of the red Ravenel ring gear and light blue rear sun gear. This is clearly visible in the cross-section view. Now, the light blue rear sun gear transfers power to the output shaft in the reverse direction and results in a reductive gear ratio of 5.14.